Okay, hi everyone. Thanks for joining. My name is Damien. And as we just heard, I'll be talking about performance monitoring. So this talk will be mostly an introduction. So I won't go into too many details. It's more to talk about the general principles and parts of performance monitoring, how you can do it, what it actually does. And this is the agenda. So as I said, first we'll be looking at what is performance. So because depending on the context, performance can mean a lot of things. Then we will look at how we can actually monitor performance. From then we go to understanding the performance metrics that we are collecting. And from this, we will move to improving the performance in a data-driven way. All right, let's jump in. So the first part is, what is performance? Performance in mobile apps refers to the degree of effectiveness and efficiency to execute tasks. A simple metric to measure this is time. So we measure the time it takes for us to complete a certain task. There are other areas we can observe. For example, the network consumption, so how many requests are we sending, how much data are we transferring. The power consumption, especially on mobile devices, it's important, right? Because we don't want our users to run out of battery just because of our app. Then we have storage and we have memory. So here's a couple of examples. Performance can be, for example, the app loading speed. That's the time until the app is available to the user and becomes responsive. It can be responsiveness in a flow, in a user flow. So for example, tapping on a button, right? If you're the user, you're expected to do something. You don't want to be stuck and not see any progress. So if the app does something immediately, it feels responsive and is a good user experience. And then another one would be frames per second. This is pretty much how fluid the whole UI will look. A good example is scrolling through a list. If you see frame drops, most likely there's some impact on the performance somewhere and something is not done in an optimal way. So the next part is how can we choose these metrics? So depending on the app, the metrics that we can observe and that we should observe are very different. The first part is we need to understand the goals and the objective of our application. We have to identify key performance metrics. This would be critical user path. So for example, if you have a shopping path, it might be good to let the user browse through items without a lot of lag or frame drops. Or it could be the checkout code path. So these would be our critical paths in the application. Then we can also consider the target audience. I'll dive a bit more into this later, but we have a bunch of audiences as our app grows. We have some users that are on high-end devices that have a stable network connection, and then we have users with more low-end devices and maybe with unstable network connections. And then for each of these metrics, we can set clear performance targets and thresholds. This becomes important once you have monitoring in place to ensure that you don't have regressions. So your app does not perform worse because of any new introduced changes. This is an example of frame rendering time. So I created a small demo app on the left. I took a small video. This is just to show that if you do too much while displaying the view, you will end up dropping frames. And it can look very bad. As you can see, this was a smooth scroll action that I did. And it's stuttering a lot. This is what we want to avoid, and this is what we can use performance monitoring for to avoid it. Frames per second this is pretty much the amount of frames we need to draw of our UI to have it in a smooth way. So if we want to achieve 60 frames per second, we need to draw the frame 60 times in 1 second. This means we only have 16 milliseconds for each frame. That's not a lot of time. So we need to think carefully what we want to do during this time. This is especially important if our app has a lot of animations or other visual effects. The next part would be, or the next example is just time to execute code. So a low time here is obviously better. We want our code to be executed fast and without any issues. A high execution time can have multiple reasons. Again, this is what we use our data later for to find out what's going on. But this can be due to, for example, large data sets that we are operating on, or expensive I/O operations like a network request or reading files from the storage. This can also be related to inefficient processing of data. For example, using an algorithm that is not suited for our data set. And then we have network request performance. This is also crucial for a lot of apps, since most of the applications we are using need some sort of data from the backend. It refers to the amount of time that it takes to send and receive data over a network connection. This is heavily dependent on the network connection itself. And it also contains the amount of data transferred. So a good performance here is also essential for providing a fast and seamless UX. Because if it takes a long time, the user will either see stale data, because you're showing the last cached values, or the user has to wait until the request finished. So one thing here is we can make sure that only data that we actually require is requested. There are some exceptions to this. For example, prefetching. This would be the case if we know that a user needs to go or progress to a next screen or a next action, then we can fetch it eagerly to improve the perceived performance of this. The next part is how to measure performance. There's a variety of tools available to assist with performance monitoring. We have native tools that are provided by the operating systems. Then we have some third-party tools, and we have custom in-app monitoring solutions. It's important, as always, to choose the right tool for the right things, for the right situation. The first one, the native tools, they can be useful for performance monitoring, and they can monitor often a very broad spectrum of performance metrics. For example, I included a screenshot of the Android Studio Profiler. It can help monitoring the performance of memory, the CPU network, and it has some overall metrics. I think it also has some energy as well, so it can also help with power consumption, for example. This can help mostly to identify issues that come up while developing an app. So you need a connected phone or an emulator or a simulator for this. So it's not a solution at scale, it's more an on-demand thing that we can do. The next part is custom in-app performance monitoring. This can give us a high level of flexibility and control. The solutions involve adding code to our code base, though, compared to the previous solution, which is just plug and play. So here we need to actually add traces to our code base, which will then be executed, collected, and we can then download them from the phone or from the device. This gives us detailed and granular data, and we can identify issues and hopefully fix or improve them quickly. However, it requires investment. Right? Investment of time and resources. And then the next part is if we want to monitor performance at scale, we will need remote monitoring. This is pretty much similar to the previous solution, just that we are not doing it locally, but we need to upload the data to a server. This can be, for example, Firebase performance monitoring or any other tool that allows it. You can also do it in a custom solution if you want to upload the traces to your own backend or to your own database. This will give valuable insights into how the app is performing in real-world conditions. Compared to the previous solutions, which are more on demand and focus on your developer experience. This will help you find out how is the performance across the user base, no matter where it is. If your user base is very local, you will still get information about it. If it's globally distributed, you will get information about the whole user base. So it allows identifying trends and patterns that may not be visible on your device. Here again, since we are dealing with user data, it is important to only collect the minimum amount of data that we need. So keep in mind, performance monitoring does not require user data, right? So all we need is the time that we need to spend in a certain flow in the best case scenario. There may be some contextual information, but we don't need user data for this. So that's important once we deal with actual users. Okay, the next part is adding performance logging. So I've added a bunch of examples. There's two code snippets here. The first one defines a function, get data. It executes a sequence of other functions and returns data. So what it does in a nutshell is it refreshes an access token. It creates a request. This could be an HTTP request or GraphQL or whatever we are pretty much using. Then we are executing this request. That's our I/O operation. So we are we're doing a network call. And then we are mapping this data, which in this term is JSON, the JSON to our data object. The second code snippet is just something on the view layer. It just calls the method and then sets the result to our view. So how can we add performance monitoring to this? The first step is to look at a more high-level approach. So we don't know where our hotspots are, where we need to dive in deeper. So we will just add a very high-level trace. At this point, what we are doing here is we create a new trace before we call the method, then we call our method, and then we close our trace. How this is done depends on the integration that you're using. If you're using Firebase or a custom solution, it'll be slightly different, but most likely it'll be a bit similar to this. This will give us insights into how long it takes to execute this method. It can be used to learn about the total duration. So that means it includes the network request, server-side processing, and client-side data mapping or processing. This is the kind of data we would get with the trace. Just imagine that each of these blocks is a specific amount of milliseconds, just some time. I didn't add any because it's just an example. In this image, I also added a couple more functions and their traces, just as an example to add items or to edit an item, which could be other of our critical user paths. So we identified that the first method, get data, takes a long time. So what we want to do is we want to find out why. To do this, we have to dive in a bit deeper and we need to add low-level traces. What this means is we will go into the get data function. We are no longer creating the trace at the call side, but we are doing it in the method itself. And for each of these steps, we add a point to our trace. Again, this depends on the framework that you're using. So it's just an example, but most of them will offer a similar functionality. So in this case, I'm adding a point before refreshing the token, before creating the request, before executing the request, and then before mapping the JSON to our data object. This will allow us to look at the data in a more deeper, so we can look at it deeply. The first bar on the top is the same that we saw earlier. It's the whole time of the execution of the function. But what we get now, because we added the low-level traces, is we get insights into how long each of these takes. So we can dive into this and maybe we will find some patterns that don't look right, or we can see, okay, this part takes a lot longer than it's anticipated. So if we are doing a local data processing, we might not expect it to take up most of the duration. Okay, so now that we have some data, let's look at how we can understand performance metrics. Yeah, so each of these is a block of time, right? So it will most likely be milliseconds. That also depends on the framework, on your database. Could be nanoseconds. And in this example, I slightly modified the data to make it more obvious. But in this example, the map JSON to data function takes a very long time. So here it takes up roughly 40% of the whole duration. And as I mentioned earlier, this is not what we are looking for. Right, so the first thought is we should try to optimize this part of the function. But instead of doing that and jumping right in, we can take a look at different ways to read the data. So since we are doing remote performance monitoring, we get a lot of these. So we get a lot of data, right? It can look a bit like this. We have, in this case, we have 5 samples. Each of them has a different execution time. We have some that take a very long time, and then we have some that are very fast. What this means is the users are likely in different conditions and different environments. Some users are on very fast internet network connections. Some users have very high-end devices. They would be most likely better at parsing our data. And some users have low-end devices, which take a lot longer to parse our data. So to read this is where it gets a bit mathematical. We can look at the curve, at the bell curve. So this will be our distribution of the time, right? So if we take all of our values and we divide them by the amount of values we have, we will get an average value. That will be in the middle. That will be our 50th percentile in this case. If we look further on the right, going up to the 95, 99 percentile, we will see the high performers. High performers, unfortunately, in this case, is not a good thing, since that means they get high numbers, which is a high duration. So to see how the worst case scenario is for some users, we can look a bit further to the right of the curve, and we will get insights into that. This will allow us to look at, as I mentioned, different user groups, different audiences, different environments. So we have this data now, and we looked at different scenarios, different percentiles. So let's think about improving the performance. So looking at the data, the rule of thumb is we can look for the most impactful improvements. So this can be seen pretty easily. The more users benefit from something, the higher will be the impact of the change. That would be a very simple way to look at this. In this example, all of the users would benefit from improving map JSON to data, because it's in the crucial code path, so every user will need to execute it. And also it's the biggest factor for both the average and the high percentiles. If we only look at the high percentiles, we will likely find some edge cases. This could be a very unstable network connection. It could be a very old device that your app barely supports on the lowest operating system version, but it still exists and it's a user of your application. So it makes sense if you have the resources to look at these cases as well. The more the user base grows, the more likely it is that we will have these edge cases. And improving on these will make our app more accessible to people in all parts of the world. So it's an important part. Lastly, a quick summary. So there are a couple of things to keep in mind. The first one is we should start measuring performance. It doesn't have to be super low level. It doesn't have to take up a lot of your time. It can be a very high level approach at first. We can just look at our critical user path, add some traces. This is important because the users are likely not using the same device and network connection as you are developing the app, right? Your phone is connected to your laptop most likely. You're on Wi-Fi, so you're in the best conditions to use your application. The users will not be this lucky most of the time. The second one is we should not only look at the average values. Looking at different percentiles of our performance metrics will give us insights into different user bases, edge cases, and will allow us to optimize for everyone in the world. Just looking at the average can show bias. So the data set will be biased depending on the user base. And the third one is make data-driven decisions. right? So if you're improving the performance, it's good to add performance monitoring before you do it. So because if you add the monitoring before, you have metrics, then you do the actual improvements. And then after that, you can show that you improved the metrics by a certain amount. Otherwise, you will not know if this actually helped. If you're acting on a hunch or if you have an idea, then it might actually not have the expected impact. All right, that's it from my side. Thanks again for joining. And if you have any questions, feel free to either just talk to me here or reach out to me on Twitter or LinkedIn. And yeah, thanks for having me.